Hey everyone, welcome to KSSP Podcast. I'm Spencer.
And I'm Katie. And today we are going to talk about mirror neurons. All right, so this is from the National Library of Medicine, what we currently know about mirror neurons. Mirror neurons were discovered over 20 years ago in the ventral premotor region F5 of the macaque monkey. Since their discovery, much has been written about these neurons, both in scientific literature and in the popular press. They've been proposed to be the neuronal substrate underlying a vast array of different functions. Indeed, so much has been written about mirror neurons that last year they were referred to, rightly or wrongly, as the most hyped concept in neuroscience. Here we try to cut through some of this hyperbole and review what is currently known and not known about mirror neurons. Mirror neurons are a class of neuron that modulate their activity both when an individual executes a specific motor act and when they observe the same or similar act performed by another individual. Ever since their discovery, there's been great interest in mirror neurons and much speculation about their possible functional role, with a particular focus on their proposed role in social cognition. Hayes wrote, "Mirror neurons intrigue both specialists and non-specialists, celebrated as revolution in understanding social behavior and the driving force behind the great leap forward in human evolution." So much has been written in both peer-reviewed literature and elsewhere about mirror neurons and their proposed functional roles. They've been recently given the moniker most hyped concept in neuroscience, like we've read before. So for us, discovering mirror neurons was exciting because it led to a new way of thinking about how we generate our own actions and how we monitor and interpret the actions of others. From a functional viewpoint, acts and execution and observation are closely related processes, and indeed that our ability to interpret the actions of others requires the involvement of our own motor system. All right, we'll look at the concluding remarks here, so we don't need to go through every single study here. So the discovery of mirror neurons has had a profound effect on the field of social cognition. Here we have reviewed what is currently known about mirror neurons and the different cortical areas in which they have been described. There is now evidence that mirror neurons are present throughout the motor system, including ventral and dorsal premotor motor cortices and primary motor cortex, as well as being present in different regions of the parietal cortex. The functional role of mirror neurons and whether mirror neurons arise as a result of a functional adaptation and or of associative learning during development are important questions that still remain to be solved. In answering these questions, we need to know more about the connectivity of mirror neurons and their comparative biology across different species. So, okay, that is the study from National Library of Medicine. So next, we have this Greater Good magazine from Berkeley, and I'm not going to donate. No, thank you. All right. Do mirror neurons give us empathy? So did you ever get a sensation where you're watching someone do something, serve a tennis ball, say, or get pricked by a needle, and you can just feel exactly what they must be feeling as if you're in their shoes? Scientists have long wondered why we get that feeling, and more than 2 decades ago, a team of Italian researchers thought they stumbled on an answer. While observing monkeys' brains, they noticed that certain cells activated both when a monkey performed an action and when that monkey watched another monkey perform the same action. Mirror neurons were discovered. Since that time, they've been hailed as a cornerstone of human empathy, language, and other vital processes. But there's also been something of a mirror neuron backlash, with some scientists suggesting that the importance of mirror neurons has been exaggerated. Then Mr. Ramachandran, known as Rama, says, "I don't think they're being exaggerated. I think they're being played down, actually." In the presentation at Being Human, Rama discussed how research on minor neurons and phantom limbs suggests an extraordinary human capacity for empathy. So if anybody doesn't know here, phantom limbs are basically like if somebody loses a limb, but they can still feel that limb there, even though it's not there anymore. Like if someone loses their arm and then they can feel their hand on that arm clenching, even though they don't actually have the arm. It's just still in their head because they're so used to being able to feel it. So that's basically my description of phantom limb. I might have butchered it a little bit, but just so people know.
Yeah.
And then there's an interview here between the author and Rama. So, all right. What are mirror neurons and how were they discovered? So Giacomo Rizzolatti and Vittorio Gales and some of their colleagues in Italy discovered mirror neurons. They found these neurons in the frontal lobes of the brain, the prefrontal areas of the brain, among what were originally found as motor command neurons. These are neurons which fire when I reach out and grab a peanut, another set of neurons which fire when I reach out and pull a lever, other neurons when I'm pushing something, other when I'm hitting something. These are regular motor command neurons, orchestrating a sequence of muscle twitches that allow me to reach out and grab something or do some other action. A subset of these neurons also fire when I simply watch another person, watch you reach out and do exactly the same action. So these neurons are performing a virtual reality simulation of your mind, your brain. Therefore, they're constructing a theory of your mind, of your intention, which is important for all kinds of social interaction. So, okay, I wonder if you can elaborate on the mirror neurons and affective experiences and emotional experiences. So he says, Rama says, I don't know much about it. All I know is they're involved in empathy for, say, touch or a gentle caress or pain. It turns out that these anterior cingulate neurons that respond to my thumb being poked will also fire when I watch you being poked, but only a subset of them. These are non-mirror neuron pain neurons, and there are non-mirror neuron pain neurons, and there are mirror neuron pain neurons. So these mirror neurons are probably involved in empathy for pain. If I really and truly empathize with your pain, I need to experience it myself. That's what the mirror neurons are doing, allowing me to empathize with your pain, saying in effect the person has experienced the same agony and excruciating pain as you would if somebody were to poke you with a needle directly. That's the basis of all empathy. So when you talk about mirror neurons and non-mirror neurons, what percentage are you talking about? So between 10 and 20% are mirror neurons. For motor neurons, I think it's a higher percentage, maybe about 20. For sensory neurons, it's about 10%, but these numbers are not all that accurate. And then, let's see, the social implications and broader practical implications of mirror neurons. So they enable me to see you as an intentional being with purpose and intention. We suggested nearly a decade ago that mirror neuron dysfunction may be involved in autism. People with autism, ironically, sometimes they mimic constantly what you're doing, but it's also true that they're bad at imitation and they don't have empathy. They don't have a theory of mind. They can't infer your intentions. They don't engage in pretend play. In pretend play, what I do is temporarily say, I'm going to be the superhero. So you do role play. That requires a theory of mind. So take all the properties of mirror neurons, make a list of them, and list all the things that are going wrong in autism. I don't really like that language.
Yeah.
But, okay. I mean, he's a scientist, so, I guess I can excuse sometimes the logical type language is just a little insensitive, but, I get what he's trying to say. Not every symptom, but many of the symptoms match beautifully. That's controversial. There are about 7 papers claiming it's true using brain imaging and maybe 1 or 2 claiming that there's no correlation between neurons and autism. Mirror neurons and autism. So some of the biggest misconceptions about mirror neurons. Initially, people are very skeptical. When people discovered that these neurons exist and exist in humans, then people went overboard and said they do everything. As I myself am partly responsible because I made this playful remark, not entirely serious, that mirror neurons will do for psychology what DNA did for biology and open up a whole new field of investigation. Turned out I was right, but it's overdone. I mean, a lot of people, anything they can't understand, they say it's due to mirror neurons. And things people attribute to mirror neurons that we don't know yet to be true. He said, my own theory of autism hasn't been proven. It's a plausible theory, better than any other theories out there, but it has not been proven but the popular person latches onto it and said that autism is caused by mirror neuron deficiency. So clearly mirror neurons provide the substrate for those skills, and maybe there are more sophisticated mirror neurons in humans than in monkeys, but they're not by themselves responsible. Those kind of errors are quite common, but that's okay. It's how science progresses. People make overstatements and then correct them. So that's the end of that interview. And then I have one more article here. It's actually, I think this is a research paper if I'm reading this right, but the mirror neuron system and the consequences of its dysfunction. So key points. Mirror neurons are cells located in the premotor and posterior parietal cortex of the macaque brain, from that monkey. These cells fire when the monkey performs a goal-directed action and when it sees somebody else performing the same action. Two areas of the macaque brain contain mirror neurons, area F5 in the inferior frontal cortex and area PFG in the inferior parietal cortex. These areas are anatomically interconnected and embedded in parallel frontoparietal networks for a sensor-motor integration. Mirror neurons in monkeys also respond to the sounds of actions and code the intention associated with the observation action. This suggests that the mirror neuron system is a key neural system for social cognition. In humans, mirror neuron area are located in the posterior inferior frontal gyrus and adjacent ventral premortal cortex, and in the rostral part of the inferior parietal lobule. The human MNS is causally related to imitation, a crucial factor for social interactions and learning. The human MNS is also it's also concerned with other aspects of social cognition, from understanding the intentions of other people to empathizing with them. Through interactions with the limbic system, the human MNS also allows the understanding of emotional states of other people. An evidence of MNS abnormalities in autism spectrum disorder is provided by structural MRI, magnetoencephalography, electroencephalography, transcranial magnetic stimulation, and functional MRI, fMRI. fMRI data shows that children with ASD have reduced MNS activity during social mirroring, and that MNS activity correlates with the severity of the disease. The higher the impairment, the lower MNS activity in ASD. So abstract. The discovery of premotor and parietal cells known as mirror neurons in the macaque brain that fire not only when the animal is in action, but also when it observes others carrying out the same actions, provides a plausible neuropsychological mechanism for a variety of important social behaviors, from imitation to empathy. Recent data also shows that dysfunction of the mirror neuron system in humans might be a core deficit in autism, a socially isolating condition. Here we review the neurophysiology of the mirror neuron system and its role in social cognition, and discuss the clinical implications of the mirror neuron system. So yeah, there's just a bunch of articles and then some references, and if you can check this out. It's Nature Reviews Neuroscience, nature.com, and then the mirror neuron system and the consequences of its dysfunction. You could probably Google search it and find it. I do have opinion I want to give here. Well, it's more of a theory than an opinion, really. So, okay, I might be a little biased, though, because I did study cognitive science for like maybe a year in college. And I've actually taken classes about mirror neurons before. So what I've learned and what I, believe from what I've learned, basically, is that the mirror neurons do, in fact, give us empathy. For one thing, like, I don't see why, if you can physically empathize with someone, why wouldn't there be other mirror neurons that would emotionally empathize with somebody? I don't see why that extension wouldn't exist. I guess it's hard for me to imagine there being a separation where the emotional isn't there. But yeah, and like they said, for autistic people, mirror neuron activity is low. But then for people with antisocial disorders, such as psychopathy, mirror neuron activity is so high that it burns itself out, and they can no longer feel the empathy, but they can still understand the empathy. And that's the difference between autism and antisocial disorder. So with autism, it's just relatively low, and you cannot empathize to begin with as well as someone who was not autistic. But with antisocial disorders, it's completely the opposite. It's too much empathy. It's so much that it burns itself out. And then you just don't feel the empathy. You just logically understand it, though. And then, yeah, like I said, these disorders be an opposite end of the spectrum of mirror neuron activity, if this is in fact true. Now, this is all theory, but this is the theory that I think makes the most sense.
That makes sense to me. And it's also just, I guess I don't know for sure, but then my theory would be that if that is the case, with the brain being neuroplastic, we can solve those issues. Not that
Okay.
they need solved, but we can help
We
people
can help reduce
learn.
symptoms.
Yes, like we can help people
Right.
with empathy, whether that's the
Yeah.
burnout and reduce fixing the burnout in a sense, or
Mhm.
helping people with autism who maybe don't have. I guess it depends on if mirror neurons work like the rest of the neuroplasticity in the brain. I don't know if we'd have any
Yeah,
studies on
and I
that,
would
but
think they would because they're very similar to the regular neurons, at least with like motor
yeah,
skills that they've studied. They say they're very similar from everything we just read. So I would think they would still be plastic. I think, like, I know, like, for example, for empathy, they like have invented different AI kind of robots almost. They're like androids or
oh,
whatever that can help people with autism learn empathy. That's one
okay,
thing I heard about when I was in school that they were doing.
that's interesting.
Yeah.
Kind of like a companion in a way.
Yeah, yeah, for sure. It would be something like that. So this is What Do Mirror Neurons Really Do by SciShow Psych.
If you read some of the less reputable corners of the internet, you might have heard strange things about mirror neurons. According to some people, they are why we have empathy and ESP and telepathy. It
Oh
probably goes
no.
without saying that most of that isn't true. They definitely don't give us superpowers, and there is conflicting research about whether they're the basis of empathy. Even if they're not, though, they are still a very cool part of your brain, and probably they help us learn from other people. The name mirror neuron comes from the fact that they fire both when you do something and when you watch someone doing something, even if you don't move a muscle. Basically, it's as if they mirror the neural activity of the person actually doing the thing. And they were first discovered in macaque monkeys in
Oh.
the early 90s. The story goes that one day, while a monkey had thin needle electrodes inserted into individual neurons in their brain, some of the graduate students, well, they went and took a lunch break. And while one of those graduate students was eating in front of the monkey, all of a sudden, there was neural activity in the premotor region of the frontal cortex in the monkey's brain. This region would normally fire if the monkey was moving, like reaching for food or eating. But those neurons were firing while the monkey was motionless and just watching someone else do those things. Further research started mapping out exactly where these neurons were, and they're remarkably specific. Like mirror neurons that fire when an experimenter grabs a piece of food wouldn't fire if the experimenter used tools to grab the food instead. But the big question was whether this happened in humans too, because these neurons were in regions of the brain where monkeys and humans differ quite a lot. Of course, your average
Oh, I
human
didn't know
study
they were that
participant
different.
is a little fussier about getting electrodes planted
Yeah,
in
I
individual
didn't
neurons.
know. And I think it's kind of cool that it didn't fire when they used the tool. So it was very specific to a human's hand grabbing the
Mhm.
banana, but when they used the tool, the monkey's brain just didn't fire. So it could
Right.
make the
Because
distinction between a tool and a human hand, which I think
oh,
is interesting.
that is really interesting, yeah. Because yeah, they obviously can see that the tool is not alive and they can make that
Yeah.
distinction in their head. Just like it's kind of similar to the way that we see human faces and things, even where it's not a human face.
Oh, yeah.
I
Like,
think it's kind of it sounds similar to that, but like you can make the distinction though in this case. I mean, you
yeah.
can still make the distinction between what isn't actually a face, but like like if you have like popcorn ceiling and you see a face in it, or like if you have like just I don't know, like a tree that looks like it has a face on it or something. Like you
Yeah, I know what you're talking. Like I've heard of that before, that
yeah.
phenomenon. And even just a house, like if the windows are situated in a specific
Mhm.
way, you can just because you're not actually seeing a face. It just you put that
Mhm.
scene together in your head, but you obviously
Yeah,
know it's not like there's not actually a face there.
right. Like even for me, like especially when I was a kid, but even now I still kind of see it this way. But like when you see like like a naked human body, like I always saw it where like the nipples were like the eyes and the belly button was like an open mouth.
Oh, I guess I've never seen
Like
that personally, but
that'd be an example for me
yeah,
personally.
that makes sense.
Yeah. I'm just kind of weird like that,
You know,
though.
I think we're all weird, so that's
That's
okay.
true.
Average human study participant is a little fussier about getting electrodes planted into individual neurons inside of their brains, so scientists used electroencephalograms, or EEGs, to look for mirror neurons instead, as they record neural activity through the scalp. Researchers had 20 subjects watch an experimenter demonstrate some motions with their thumb and index finger, and then perform the same motions themselves. And turns out some regions of their brains did act like the monkey's mirror neurons. Parts of the motor and premotor areas of the frontal lobe, for example, as well as where the parietal lobe meets the temporal lobe, an area involved in vision and focusing attention. But knowing that they're there and where they are doesn't tell us why they're there. Many neuroscientists now think that they help us learn from other people through observation. Take a 2009 study, for example, which looked at how these parts of the brain are active while people were being taught how to dance. The researchers used a game similar to Dance Dance Revolution and varied whether the participants were taught the steps using symbols on a screen or a human model in addition to the symbols. And they found that parts of the mirror neuron network really tune into human actions. For example, the superior temporal cortex was more active while watching a person demonstrate the dance than the symbolic breakdown of the steps. But perhaps more to the point, the participants' performance on the final dancing test was better when they had a human to watch, which suggests that these regions support observational learning.
Now, I think that's really cool. I think that's really helpful in terms of helping anybody learn and helping different people learn in different ways.
Just the visual
Having a
aspect
human
of it too.
example,
Yeah,
because yeah, it'll fire the certain parts of the brain where it feels like you're doing that activity yourself versus if you just looking at a screen and like looking at the symbols and trying to learn that way.
and I find it interesting how, like, we monkeys mirror neurons fire in response to human actions, and human actions fire in response, or human mirror neurons fire in response to monkeys' actions. So I wonder if
Yeah,
that would be similar with other animals, or if it's
right.
specifically monkeys because we, in theory,
Are closely
like have a
related.
same ancestor. Yeah, or yeah,
Yeah,
have some sort of
we're
line of evolution or something.
yeah, we're
Yeah.
more like genetically related to monkeys than like a lobster or something. You know,
Yeah, but if a lobster gave a thought, like I guess,
but like if I feel like if a
but
lobster
that doesn't
did
look
something
like a
that looked like a
hand.
thumbs
Hand.
up, like you would still feel it a
You
little
think
bit.
so?
I don't know. That'd be interesting to study, though. I think it'd be cool to do a study like that. Just take some
Or
monkeys and
like
some
a
lobsters and have them do different things and see when the mirror neurons fire.
yeah. It'd just be. I mean, I don't really. We don't need. I don't think it's necessarily gonna solve anything or tell us anything, but it's just an interesting. I'm
Right.
just
It would just
curious,
be
I
an
guess.
interesting thing to study, though. I don't
Yeah.
know. I
Yeah.
mean, but you never know. Because, like, with science, it's really cool because sometimes in science you invent something and then, or like you discover something, and then that thing later becomes something sometimes completely unrelated to the initial discovery or invention.
Yeah.
You know
That's
what I mean?
true.
Like,
Science is cool
yeah,
like that,
science can
and
lead to
just
all kinds of things that you wouldn't expect.
yeah.
Human mirror neurons aren't exactly the same as the monkey ones, though. Ours seem to care about the actual movement, while theirs are more strongly tied to the movement's meaning. Like,
Okay. So we care about the movement and the monkeys care about the movement's meaning, is what you just said, right?
I think so. I guess I don't know.
So that makes sense.
What?
Like, I think he's saying with the monkeys, it's more lights up, like, um, based on, I guess, like what the intention of the action is. Whereas with humans, it's more focused on the action itself, I think is what he means. Like,
Okay.
does that
I
make
guess
sense?
kind of.
Okay.
Wouldn't it be the opposite way though? Because
You
we're
would think
humans
so.
have more.
That's what I would.
Did he say?
Let's see, because he's about to
Okay.
explain it here. I think,
Okay.
like you said, let's say you grab a water bottle the way you normally would. Okay, let's see.
Say you grab a water bottle the way you normally would, and then you put it down and grab it with your hand like upside down instead, which makes drinking it a lot harder. It's basically the same muscle motion either way, but one serves a meaningful function. In a macaque, watching the meaningless action might not activate their mirror neurons. But
Okay, so that would mean we're more evolved in that sense then. Because if he's about to say we're able to still detect it when the hand's upside down and the function isn't like proper or whatever.
Oh, then we can make that distinction. I mean,
I
obviously
mean,
we
we can make
can
that
make that
distinction, but we'll
distinction,
still
but
the mirror neurons will still fire either way. Whereas in the monkeys, if the hand is upside down and all messed up, like grabbing it, then they won't detect it.
that's so odd though. Still, like I,
That's interesting. Yeah,
yeah,
I wonder why that is. Well, it's probably because we're more
yeah,
evolved cognitively, but
maybe. I mean, yeah, because the only reason I could see them not firing is because they don't feel the need to like feel that because they know that it's pointless or like I don't know how
right,
to
and that's what
explain it,
he's
but they
saying,
just
like because of the intention, and like
but that's just interesting that
yeah,
I don't know.
But in people, the mirror neuron regions of the frontal lobe activate regardless of whether the action makes sense. All that matters is the actual hand motion. It's possible that this helps explain why humans are so good at learning by imitation. Part of our brain is always paying attention to motions that seem meaningless, just in case we can learn from them. Now, you might be wondering where empathy comes into all this. Well, when you think about it, if a part of your brain activates the same way when you're observing an action as when you're performing it, then it isn't that far of a stretch to think that these mirror neurons could be involved in feeling part of what someone else is feeling simply by seeing them express an emotion. And although this would be very cool if it were true, the research to date is kind of all over the place. Like one study did find that mirror neurons activate when people empathize with characters in scenes. In one scene, for example, the 18 subjects had to identify the emotions felt by both a son who was bringing home a failing report card and a dad who hasn't yet seen it, for example. And in addition to identifying the emotions of both characters in the story, they had to guess what both characters would be experiencing if they had more information. One of the mirror neuron regions, the inferior parietal lobe, was active while identifying the emotions in the story. And scores on a test of empathy were related to how active that region got when they had to make an inference about the dad who was still in the dark. Not all studies
But
show this,
wait,
though.
can you pause
oh
it
yeah,
for I
yeah,
have a question. Isn't aren't for the most part mirror neurons supposed to just be natural though?
yeah.
Like they just are supposed to happen? We're not. I guess I just am confused
What are
because
you
in
trying
that
to say? I guess I'm a little
scenario, in
confused.
that study, they told them think about how the person would feel. It wasn't just letting your brain respond naturally to how the
Yeah,
character would feel. They said think about, so that you were you obviously they're going to use their brain to think about. Like I
yeah,
don't
but
know.
I
I'm
think
just
it's
saying.
because when they're using their brain, like when they're instructed to do so, the mirror neurons are still active, right?
But I feel like it's hard to determine because obviously when I'm going to use my brain to think of an emotion, then it's going to fire compared to like I just
Yeah,
wonder
it's just
maybe if a study was more focused on you not having a guideline of what to do, but then like let's say a friend comes and tells you good news, but you're not supposed to like you're just supposed to let your brain respond naturally.
yeah,
Like I don't know.
and
I just feel like
I
instead of
get what you're
telling them
saying.
like feel what the other person is feeling because then obviously those brain regions because you're trying to do it
Yeah,
like you are
but
actively trying to feel
right.
it.
But if you're
It's not
feeling what they're feeling, like it's not just the emotional parts in your brain that are lighting up, like that would light up if you were feeling the emotion from yourself. But like while that's happening, like at the same time, like your mirror neurons in that part of your brain, what was it? The oh, I can't find it. Yeah,
or parietal,
the
I think
parietal, yeah.
one of the parietal
Yeah, one of
areas.
the yeah, something parietal lobule, I think.
Yeah.
the IPL, it like was still firing. The mirror neurons were still firing, like when they were trying to empathize with somebody else. But if you were feeling your own emotions, I think like the emotional part of your brain would still be fired, but like the mirror neurons might not be fired if it's your own personal emotion. Like, do you know what I mean?
Kind of.
Okay.
It, it just depends on how they're
It depends
what
on how
you're
the study's conducted. I mean, that's always an important factor when you're looking at studies.
yeah, and I guess even with the previous studies too, like were they telling these people when they see someone reach out and grab a water bottle to think themselves of grabbing a water
I
bottle? Because
don't
it should
think
just
they're
be
always doing
natural.
that.
In my head, mirror
Like,
neurons would just be a natural response to
right,
seeing
like
it,
that
not a
one,
forced response.
yeah, like there was that one study where they didn't tell them how to react, but they just told, like, they just connected the stuff to their head and just had the person do those motions or whatever, like thumbs up or whatever they're doing. And then
Yes,
they would have
yeah,
to repeat it themselves. And then they would see when the what neurons were firing in the brain during each of those interactions.
yeah,
And so that one I think was more natural. I don't think they told them how to do the study.
yeah. And I'm not saying that that means anything negative or positive about it. It just
Mhm.
is something that I thought of that I
Yeah.
feel like because if you're telling someone to do something, then they're gonna have because if somebody tells me feel happy, then I'm gonna actively try to feel happy, and I know what you were saying, I guess, about if someone tells me think of like Katie feeling happy, maybe that would light up different brain regions compared
Right.
to if I was thinking about me being happy.
Yeah.
I guess that could be something they could look into versus like if I'm feeling an
Right.
emotion thinking of myself versus if I'm feeling an emotion thinking of someone else.
Yeah.
But I still think that is still an active thing. And I guess to me, I assumed mirror neurons were more of just the passive thing, not an active response. But I guess I don't know for
Yeah.
sure. I don't know a lot about mirror neurons personally, so I'm learning.
No, yeah, I get that. All right. I'm gonna play this if that's cool.
Yeah,
Okay, cool.
Fact, many do not. But then
Wait,
again,
what
most
did you
still in
say?
the dark. Not all studies show this, though. In fact, many do not. But then again, most studies in this area have small sample sizes,
Yeah.
so there's a chance that there are real relationships between these neurons and empathy that aren't being detected. And just to make things more complicated, these studies are all correlational. They can say that there's a relationship, but they can't directly infer causality, which
Interesting. Now, how would you infer causality here? Is what I'm
I
wondering.
don't know if you ever could.
I mean, you would have to like
It'd have to
dig
be
into the
micro.
brain pretty much.
Yeah, we would need nanobots at that point, which I don't.
Yeah,
Well, I think.
microchips in the vaccines.
Well,
No,
no,
I'm
but I
just
think
playing.
your friend or not friend. I how do I? Somebody is making a brain chip. Somebody who owns Twitter is making a brain chip, so
Oh
we'll see. I don't know
no.
what he's doing with it, but we'll kind of see what
Is
that.
he really? Wow.
Yeah, I think
Is it a
2000,
is it a Twitter brain
1000.
chip that
I don't
lets you
know,
see
but
Twitter just through your eyes forever?
ugh,
That would
I
be
think
awful.
like
That would be awful.
1600 plus animals have died in the
Oh
study.
shit.
So I don't know
That's not
how
good.
say yeah, it's I don't know much about it. I haven't looked into it. I only see what I see online and that could all be propaganda. So I'm not going to make a comment on the validity of it. I haven't looked into it personally, but see he's trying, so I don't
I
know.
mean,
We'll see
well,
how that turns out,
and I
but
guess
then
yeah. Yeah, because how do you infer the causality of any neuron action? You
you'd have to
know,
have like nano like you'd have to have a nanobot that could
like
detect like could actually physically
do they
detect
have
it.
causality determined between like dopamine and motivation, for example? Like, how did they determine that causality? You know, because it's pretty widely accepted, but I don't know if there's a causality behind it or if it's just correlative. I would have to look into that.
I think it's just a theory right now still because there is no
That dopamine
you
produces motivation, you mean?
yeah because how can you
How can
1000%
you
prove.
physically prove that without like dissecting a human body? You know, I guess nanobots would
Nanotech,
be.
yeah, nanotechnology. We're gonna have to develop medical. If, but do we need? I mean, I think it would be useful, especially for mental health disorders, if we,
Yeah,
because there's all these theories about the biochemical
yeah,
ration or reasoning behind why
yeah.
mental health disorders exist, but we don't have any true, like, there's no definitive proof
Right.
on. I mean, you can claim that since we take medications for our ADHD and it helps, that's definitive, but it's still not
But it's
definitive
not.
proof.
It's
It
just
could,
correlative still.
yep,
It's
exactly.
not causational.
So we'll never. I mean, maybe in the future, I would hope we would, because I've always thought it would be cool to develop technology that could legitimately measure the level of the neurochemicals in your synapses. But
Yeah.
we need nano,
There's a
like
lot more
specific
we got to learn
technology.
before we do that too.
Yes, and when you're developing that, you have to take into account the immune response, because our
Oh
bodies
yeah,
do not like foreign objects. So
right,
that is a big thing we have to take into. There's a lot you have to take into consideration.
right.
I'd love it if we could work on developing that, though. That'd be
That would be a good
like a
development.
cool project, yeah. But I don't know, not anytime soon. I don't see that
Yeah.
happening.
Means in the end, we don't know if these brain regions are necessary for empathy or if they just happen to light up when we're experiencing it for some unrelated reason. Like with so many things, especially in brain science, we need more research to figure out what role, if any, mirror neurons actually play in empathy, or if they're a part of why humans are an unusually social species. They do, however, seem to be a big part of how we learn skills through observing others. And that means they're probably an important part of how we share skills and behaviors and pass knowledge down from generation to generation.
So okay, I have a theory here. Another
Yes.
theory. A game theory. No, not a game theory, but a science theory. So they're saying that mirror neurons are pretty important in the function of like learning from other people. And of course, let's say, as we talked about before, if you are autistic and if it is true that that means you have less mirror neuron action, if that is true, then I would, I mean, that would obviously make that a learning disorder, which it is.
Yeah.
But with like people who have hyper empathy, I would think it would also be a problem because with hyper empathy, like you're not just getting the useful information within your mirror neuron system, like you're also absorbing, not absorbing, but like, you know, you're also taking in unnecessary information. Like, I don't know if you've seen that meme where it's like ADHD highlighting in a textbook and like literally the whole page is highlighted, like all
Yeah.
colored in with highlight,
I
which I
I
mean,
don't think
I
I've
used to
seen
do all
that
the time,
meme, but
honestly.
I do that. Yeah, that's what I always did when
Yeah.
I was studying for, like, not nursing exams, but when I was when I first went to college, I would highlight everything and
Yeah.
I'd be like, "Oh, this sentence is important. Oh, sounds important. Oh, this one too." And then I'm like, "Damn it. Like, I just highlighted the whole book. This was pointless."
Yeah,
But
exactly. Oh, I've done it so many times. But like it's kind of like that, except within your mirror neuron system. So you're taking in all of the information, not just the essential information. So I would think that would also make, you know, that would also lead to learning disorders, like especially because like both hyper empathy and like very low empathy are common with ADHD, for example. Like at
yeah,
least, you know, from what I've observed from, you know, other people's experiences and my own experiences both together. Like it just depends on the person. But
I think I in my head, so this is just I don't I'm not going to claim this as fact. This is just my thoughts, but again, it also, to me, I think it just comes down to a very hyper active nervous system,
yeah.
especially with sensory overload too.
Oh yeah, absolutely.
Like, our nervous systems just are hyper.
Yeah.
And I think sometimes that also, especially like how we talked about rejection sensitive dysphoria with
Hmm.
ADHD, and how you can physically feel pain in response to emotions. I
Yeah,
almost wonder if there's
I would.
some mismatch crisscrossing
Yeah, I
between
would
mirror
think there'd be
neurons and
some
our normal.
correlation between RSD and hyperempathy.
Oh yeah, 100. I'm not going to claim that, but that
I
I
wouldn't. I
agree.
mean,
I
I'm
would
not
agree with
claiming
that.
that it is
No,
definitely true,
yeah.
but I would say I'm just saying I wonder if that is a possibility.
I think they're all related in my
Yeah,
opinion, cuz
it's all in the
whenever
nervous system.
cuz I also not only feel rejection extremely intensely and like physically, but I feel happiness extremely intensely and physically, and I feel all of my emotions. So to me it's not just a rejection sensitive dysphoria, it's almost like an all emotions dysphoria because I feel everything. And but that's just me.
Yeah.
I don't know if I'm not going to claim that anybody else feels that or that that's the reasoning that I feel that way, but to me that just makes sense because
Mhm.
my it's almost like a well, and that's just more the crisscross like mismatch maybe between feeling other people's emotions and feeling my own.
Yeah.
And that's where I sometimes feel like these mirror neurons, when you have hyperempathy, like you can't distinguish those emotions from your own emotions. So you feel them as if they're your own. So it's almost like these neurons are
Yeah.
getting crisscrossed or mismatched. So I don't,
Or I think that yeah, they might just be hyperactive. But I mean, they
yeah,
could.
but it's
They could.
still
I
interesting
mean,
that like,
the neural pathways could also be mixed up with each other. I mean, we haven't really studied it enough to know for sure.
yeah,
I mean,
just
that
because
could be
like,
another theory for sure.
it's just interesting that only some people have hyper empathy in the because I guess have they done studies on people with hyper empathy compared to people with
I don't think
supposed
they've done
normal
studies with
empathy?
that in relation to mirror neurons. I don't think they have, but I think they should.
Because it'd be interesting to see if they light up more places for a hyper
Right. Like if they light
empathic
up in more places or
person.
if their pathways are misdirected or maybe,
Yes.
like you said, crisscrossed, for lack of a better term. But yeah, like I think, yeah, definitely possible that um, hyper empathy would definitely like even lead to like it could even be considered some kind of learning disorder if you're not able to properly extract the information you need to learn.
Yeah, because it's hard to appropriately learn from others' experience. Like you're all what because it's almost too much information to where you can't process it in a way.
Yeah.
I would say like you can't process what's important and what you need to gauge from the situation.
Yeah. Okay. We're almost done with this video here.
Okay.
So no matter what, they are a big deal. They likely are playing a huge role in culture and in all those things that just make us human. Thanks for watching this episode of SciShow Psych, and a special thank you to all of the people who support us on Patreon, because we really couldn't make this show if it weren't for you. If you'd like to learn more about
All right. Patreon.com/SciShow if you want to donate to them. What do mirror neurons really do by SciShow Psych? Oh, that was that video. All right. This is Mirror Neurons by, I'm going to butcher this, but De Blauwe Zon Purmerend.
Okay.
So this is mirror neurons from the empathic civilization. Let's see.
Let me take you back to the early
there we go.
1990s. Sleepy little laboratory in Parma, Italy, and scientists had a MRI brain scanning machine on a macaque monkey as the macaque monkey was trying to open up a nut. They wanted to see how the neurons would light up. So the monkey's trying to open up the nut, the neurons light up, and just by serendipity, and this is how science sometimes happens, a human being walked into the laboratory. I don't know if it was by mistake, and he was hungry. He saw the nuts and opened up one of the nuts and tried to crack it open. The macaque monkey was totally shocked because who was this invader in his laboratory? And he didn't move. He just gazed at this human trying to open up the nut, just like he had done a few seconds earlier. And then the scientist looked on the MRI brain scanner. The same exact neurons were lighting up when he observed the human being opening the nut as when the monkey opened the nut. And the scientists had not a clue as to what this was. They thought the MRI machine had broken. They then began to put MRI brain scanning machines on other primates, especially chimpanzees with our big neocortex. Then they went to humans. And what they found over and over again is something called mirror neurons. And that is that we are apparently soft-wired, some of the primates, all humans. We suspect elephants. We're not sure about dolphins and dogs. We've just begun. But all humans are soft-wired with mirror neurons.
So that's interesting, the thing about elephants, because you were talking about the elephant in your
Yeah.
memory the other day, and how that elephant like went to that lady's funeral and then like, stomped it all up. So like,
Yes,
I'm wondering,
he had a grudge.
yeah, and I'm wondering if the
But
empathy plays a role in that at all.
I think it does. Or I again, we don't know for sure,
Mm-hmm.
but I would think that it does.
Yeah, like if elephants are able to feel that much intense emotion, I would think they would have active mirror neurons, but maybe, I mean, that's just the theory. Yeah.
That if I'm observing you, your anger, your frustration, your sense of rejection, your joy, whatever it is, and I can feel what you're doing, the same neurons will light up in me as if I'm having that experience myself. Now, this isn't all that unusual. We know if a spider goes up someone's arm and I'm observing it going up your arm, I'm going to get a creepy feeling. We take this for granted, but we are actually soft-wired to actually experience another's plight as if we are experiencing ourselves. But mirror neurons are just the beginning of a whole range of research going on in neuropsychology, and brain research, and in child development that suggests that we are actually soft-wired, not for aggression and violence and self-interest and utilitarianism, that we are actually soft-wired for sociability, attachment, as John Bowlby might have said, affection, companionship, and that the first drive is the drive to actually belong.
That's true. We are very social creatures, and I want to go back. Yeah, it's interesting. So we're not hardwired for aggression, violence, self-interest, or utilitarianism. That makes sense. All of those things would be learned behaviors then, versus
Yeah.
our natural sociability, attachment, and affection, and all of that, and wanting to belong. Like those would be more natural. Those would not. I mean, you can teach people those things, but like they're not inherently taught to you. Like usually you're born with this sense, and if you're not, most of the time there's a some kind of psychiatric disorder going on, like if it's not your natural state. Now that doesn't mean people can't learn aggression, violence, self-interest, and utilitarianism and throw this stuff out the window without having a mental disorder, because like I said, learned behavior, anyone can learn that behavior. But yes, the natural state is basically for feeling belonging with your community. I'd say to sum it
Yeah.
up.
And I guess I've always just personally assumed that. That's why when we were talking about psychedelics, it would be hard for me to assume that the natural human response that, like, sometimes you can go to, I feel like, when if you've ever done a psychedelic, to me that wouldn't have made sense if that natural or feeling, that natural state would have been bigotry and hatred.
Yeah.
Because I don't think, because like and they don't feel good either, as we talked about before.
Right.
When we were talking about transcendent emotions.
Yeah.
Those emotions, hatred, bigotry,
They don't
greed,
feel
they
good.
just don't, and they feel heavier
And
than
honestly,
love and compassion.
I would wonder if they even have an impact on your body. That would be an interesting
Oh, I
study.
would say they do. But
I would
again,
think
I don't,
so. That would, my
that's our
hypothesis
theories.
would be yes,
Yes.
but we haven't done the study or anything, so we don't actually know. But that would be the guess. Would be, I would think like things like bigotry and hatred and all of that are terrible for your body. I would
I
assume
wonder
they would
if you
raise
measured,
cortisol, especially if you're in an
yes.
environment around diversity and you're not open to diversity. That would definitely raise your cortisol levels. I would think. This is just what I think. This is not fact. Like, this is not determined fact yet. But yeah.
Yeah, I was going to say they should do some studies measuring the level of cortisol and hormones in people who are more bigoted comparatively to people who aren't. And even they could do a study where I mean, I don't know how or ethical it would be, but just have some people for 7 days meditate and then have the others maybe engage in fear and hatred filled media that's
Yeah.
trying to push narratives and then measure their, because either way the media affects our cortisol. I mean, I feel like we do need science and studies to
Mhm.
prove that. But in my head, that just makes sense. Whenever I'm watching media that's trying to fearmonger me, of course, I feel that physically raising my blood pressure
Yeah.
and stress response. Like I can feel that physical response in my body. I can feel a difference if I were to try to meditate or then compare that to when I'm watching media. I feel that that's like a real physical
Yeah.
response. We just need the studies to prove it, to have the actual evidence that let other people know, I guess. And maybe I'm wrong. I'm not saying that I'm right, but I do feel something. I feel a difference
Right.
compared
Like you
to
feel your
feeling
body
love.
tighten up and you can
Yes,
feel
I
that
feel
fear,
that.
like all of the physical aspects that come with fear and anxiety.
And hatred and
And
anger
yeah,
and any of those.
for sure. But yeah, I think that anger and hatred is really rooted in anxiety most of the time, though.
It could,
Or like
yeah, it
it's
could
usually
be.
rooted in more deep like anger is like what I've been taught, at least through therapy and everything and by psychologists and all that, is that anger is more of a surface level emotion and there's usually a deeper emotion that's attached to it that people don't want to acknowledge.
I mean, I agree with that.
Yeah, I mean that's what you
I
learn in
think
like
it's
anger
just,
management and stuff.
yeah, and a lot of it's going to come down to in like your inner personal self
Yeah,
is what it comes down to fix, because it's really not other people. Other people, even though we want to think other people are in control of our reactions, they're not. So when you're
right,
angry at someone, there's some internal, I mean, and I'm not like, yes, you can be angry at someone if they attack you. That
right.
makes
And I mean
sense to
there's
be angry at
situations where
them.
anger is warranted and just
But being angry because someone's gay,
oh god.
that's not anything to do with them as
Right,
a
and it's not
person. That is
hurting you
totally to do with you.
because anger
That is your own internal biases.
because anger is a feeling of unfairness ultimately. You feel like something is unfair and that makes you angry. And so being angry because someone is gay, like what's unfair about that to you? Like is it
Exactly.
because you want to experiment and be gay? Is it because you just want everyone to be straight like you and live your lifestyle? Is that why you think it's unfair and you just feel entitled to that control over others? Like, or is it that, there's a lot of things it could be.
You got to do self reflection. It's
Exactly.
internal. It's
And
not
you
an
need to have
external thing.
honesty with yourself.
Yeah.
Always. Yeah.
I want to go, just because I don't want to misspeak on this elephant situation.
Yeah.
I just have an article here quick I want to read, just
Okay. Can I
because I want the facts.
can I
Hmm?
finish this because it's literally just like 8 seconds.
Oh, yeah.
Can
Sorry.
we
I
just
thought we were
finish
done
the
with
video?
that.
Yeah. And then we can
Yeah.
go to the article.
Okay.
companionship, and that the first drive is the drive to actually belong. It's an empathic drive.
All right. Cool.
Okay. So I'm just going to read it here. I just do not want to give this deceased woman a bad name if she didn't actually do anything. So I just want there to be fat. I don't want to.
Did you read the article yet? Or are you reading it now?
Not yet, but
Okay.
I'll read it here. So this is from Denver 7 ABC News, I guess. So I mean, I'm going to trust them. I hope that they did their own research too. But so report elephant kills woman, then returns to funeral to trample her, which that we did mention. So here they say the effects of climate change and expanding global populations have been a lingering concern for governments worldwide. Still, as communities expand, humans and wildlife begin to live dangerously close to one another. The Worldwide Fund for Nature reported that in India, it is estimated that up to 300 people per year are killed by human elephant conflicts. In June, India's PTI news service reported that a 70-year-old woman in the central East Indian state of Odisha was killed by an elephant, only to have the same elephant reportedly return to her funeral to pull her body from a pyre and trample her again before fleeing, police said. The woman, Maya Murmu, had been collecting water in her village in the morning when the wild elephant reportedly attacked her, according to police station inspector Lopamudra Nayak. I'm probably butchering these names, I apologize. Authorities said the elephant had escaped from a wildlife sanctuary. Murmu later died of her injuries in a hospital not long after. While family members were paying their last respects, the elephant returned and pulled the woman's body from the pyre and trampled it before running away. In 2020, a farmer in India was killed after a herd of elephants reportedly attacked him in the early morning hours in a village in central East India. The 50-year-old man was in his fields working when a herd came and he was attacked. The National Library of Medicine published an article earlier that year on a phenomenon known as crop raiding by Asian elephants. These incidents are when elephants seem to cross through farmlands looking for food and water while trampling crops and ruining them. The fragmented landscape in eastern India is causing a reduction in natural habitats for these elephants, leading to the lives of humans and elephants colliding dangerously. The study authors wrote in the publication, within such shared landscapes, poaching, habitat loss, and extent of human-elephant conflicts affect survival and conservation of elephants. HEC are severe in South Asia, with increasing attacks on humans, crop predation, and property damage. Such incidents reduce societal tolerance towards elephants and increase the risk of retaliation by local communities. Duncan McNair, a founder of the organization Save the Asian Elephants, told Newsweek, elephants are generally benign and passive, he said. They don't rush out of nowhere to attack people that pose no threat to their safety or babies or anything like that. He said that the incidents, which show no provocation,
Yeah.
yes, are surprising. WWF says worry has arisen over human retaliation after communities see elephants become a dangerous nuisance. In 2001, more than 60 elephants were found dead in northeast India, and Sumatra said to have been poisoned by farmers. So it sounds like there's a lot going on. It sounds like it's a very, I mean, I would say global warming, climate change, it seems to be a big factor because the elephants are losing their natural habitat, causing them to have to be closer to humans. But it also does speak volumes if elephants are naturally, like, not naturally aggressive, that they are being more aggressive. They're probably feeling attacked as well.
Yeah, and they
So
could
it's,
even feel like the people are intruding on their space now that they're closer to people.
yeah. So it's just, I would say, an unfortunate situation for everyone involved in that situation. And then I just had one little fact here because I Googled, do elephants have empathy? And what the top Google thing said, elephants are considered to be one of the world's most empathic species. So I just thought that was interesting too, because, yeah. So I just wanted to make sure that, speaking about that elephant case, I said at least all the what we know about it. I wanted to make sure that I wasn't making erroneous claims. I don't know if that's the right word there to use right there, but just crazy claims that, because I don't want to contribute to false news or false narratives if I can prevent that. So, but yes, so wanted to do that too.
Yeah.
But I don't know if you have anything else.
No.
Just in general. No. Okay. So you guys can leave a comment below letting us know what you want us to talk about in future episodes.
Yeah, and you can find us on YouTube, Facebook, TikTok, Instagram, and Twitter, and we do sometimes do Twitch Live, so watch out for those.
Yes, so make sure to like, subscribe, and turn on notifications so that you know when we do. Otherwise, we will see everyone next time.